So this new section is polygons. So chapter 5, section 4, polygons. It's supposed to be an O. Polygons. And poly just means many. So really we're looking at like many-sided objects. So the official definition is a geometric figure. That's the whole geometry. Geometric figure with how many sides? Has to have at least how many sides? A lot of times people want to say one, but can you have a one-sided object? The fewest number of sides you can have and still have like a physical shape is 3. 3 sounds right. With 3, I'm going to do 3 plus sides, just to keep it short. Because you could have a triangle. I wouldn't draw this in. You could have a triangle. You could have a square, but you couldn't do a side. You couldn't do a two-sided object. It's not filled in, so to speak. We classify them or we name them by the number of sides. So classified, put into groups by a number of sides. And as you go on further in geometry class in high school, they'll start talking about like dodecahedrons and stuff like that. But we're just going to do kind of some of the more simple ones. A three-sided object is called a triangle. And, tri is the prefix for 3. A triceratops, a tricycle. So 4 is a quadrilateral. Back when I was a little kid, you used to be able to buy 3-wheelers, and they found 3-wheelers are horribly unsafe. You slam on the brakes and turn, it rolls on top of you. So now they started making quad runners, but the 4-wheel ATVs. Big building heads our defense. The United States. The 5-sided Pentagon. Nice. So Pentagon. Hexagon. Oops, forgot to give you a chance to guess it. Hexagon is going to be 6-sided, where hexa, or hex, is like the 6. Then the last one we're going to do is 8. Anybody remember the 8 one? What was it?
Octagon.
Nice. Octagon. Octagon. Where hex and oct are those. Feeling okay? Then from there we want to kind of break it up differently, that we could either have like regular polygons or non-regular polygons. So I'm going to say a regular polygon. When you think of like a polygon, when you picture it, that's probably going to be a regular polygon. So all sides and angles are congruent. So all sides and angles are congruent. And we struggled a little bit, I think, with what congruent is on the quiz. But that congruent basically just means the same. So I'm going to try to draw it the same, but you have a hexagon. Kind of have to go down and meet in the middle. So something like that. But if I did my hexagon correctly, you should be able to put the little dash on all those sides. All those sides should be equal in length, or all the sides will be congruent. And all the angles should be congruent also. I don't know if we talked about that yesterday, but if you put like a single little like lip around each one, that's supposed to say that the angles are the same. So all the sides and the angles are congruent. So that would be a regular polygon. If we were looking at like a non-regular, and I'll come back down to that picture in a second, but if you were to have a non-regular pentagon, that's just going to be some random 5-sided objects. 1, 2, 3, 4, 5. So that would be like a non-regular pentagon. So non-regular. How many total degrees in a hexagon? So I'm going to say, I don't know if this is really an example, but we'll say how many degrees in a hexagon. Because triangles, we said, had how many degrees? 180. And we said quadrilaterals, 4-sided objects, total number of degrees is 360. How about a 6-sided object? So if you were to take and draw a 6-sided object, it probably is going to help you if you have it drawn. 1, 2, 3, 4, 5, 6. It doesn't have to be regular. So here's how you could figure it out. We know that a triangle is going to be 180 degrees, right? So a triangle is 180 degrees. So if we take and say, well, I could try to turn this thing into triangles. If I take and cut a line here, do you agree angle 1, 2, and 3, that adds up to 180? And then if I take and do this triangle, 4, 5, and 6 add up to another 180. And then I have another triangle, 7, 8, 9, 10, 11, 12. So basically my hexagon is going to be 4 triangles, right? Each of those triangles, now if I take and say, well, I have this angle, these 2 triangle angles, these 2 triangle angles, these 2, this one, and all 4 of those together, basically 4 times the 180 is going to give me 720. So it is the 720, and that's kind of why you could break it up into triangles. If you didn't want to do that, you could instead try to break this thing up into 2 quadrilaterals. And if you just cut one line through here, do you agree the one on top all the way around is going to be 360? The one on the bottom is another 360. So 360 plus 360 is 720. So you can kind of go through and try to prove it different ways. Now, sometimes the triangles are going to work when you may have more trouble trying to get it in a quadrilateral. But let's write this thing down, then we will be done for the day. So I'm going to say in red, or maybe put a star. You want to probably put something by this because it'll make it easier to find. So to find the total number of degrees in a polygon, you could do a couple different things. One option, kind of like the either or, you could break into triangles. So break it into different triangles and do 180 times the number of triangles. Does that make sense? So 180 times the number of triangles. Another option is to just kind of learn the equation. And the way they write it is this here. They say the sum of the angles they say that equals a capital S. And the equation then is going to be n minus 2 times 180. So the sum of the angles, or S, is n minus 2 times 180. And the key is that n equals the number of sides. So the example we did, we had a 6-sided object, and then we were able to break it up into 4 triangles. So we did 4 times 180. If we had done an 8-sided object, if we'd done an octagon, you'd be able to get 6 triangles in there. So it's 6 times 180. So it's really kind of either way. If you can remember that equation, that'll make things a little faster. Otherwise, if you get one, you're kind of like, what was it? Don't have the equation handy, just draw triangles through it. Pick one corner, one vertice, like so to speak, like I did with that one there, and then just break it up into triangles, count how many triangles you have. Any questions we should go over together?